This video is covering section 1.4 in your trigonometry book. We are going to use some of the definitions that we learned in the last section. We learned about the 6 trig functions, and then we're going to talk about our first set of formulas, which are the reciprocal identities. We talked a little bit about those in the last video, the Pythagorean identities and the quotient identities. So in the last video, we said that there was this pairing of the trig functions based on the relationships of the triangle for x, y, and r. As a reminder, we were looking at, say, a triangle that's drawn in the first quadrant, like this, where the angle is sitting right next to the origin. The x-coordinate is here, or the y term is here, and r is here. And we had this relationship, sine was y over r, and cosine was r over y, or cosecant, sorry, was r over y. So they were reciprocals of one another. All this slide is telling you is that if you take these two together, they are going to be reciprocals of one another. These are reciprocals, and these are reciprocals. I think rather than thinking about it in this format, it's easier to think about it the way we were in the last video, where we just took the fractions and flipped them upside down. But you do need to memorize these relationships. So, as an example, secant and cosine are reciprocals of one another. So if I know that the secant of the angle is 5/3, then that means that the cosine of the angle is 3/5. Similarly, sine and cosecant are reciprocals. So if I know that the cosecant of the angle is negative square root 12 over 2, I can say that the sine of the angle is negative 2 over the square root of 12. Some of you may have learned that it's considered to be grammatically incorrect to leave a square root symbol in the denominator of a fraction. This comes from a long time ago when we didn't have calculators very readily available, and we would look up the values of square roots in textbooks. There were tables that had values in the back. There are a lot of calculators that will what's called rationalize the denominator for you. But I'm going to just show you on the next slide how to do that, and then we'll come back and complete this. One of the common fractions that we'll come across in trigonometry is something like this, the square root of 2 over 2. And it might sometimes show up in a different format, say 1 over the square root of 2, like this. When I have a square root in the denominator, what I do is I multiply by the exact thing that I'm trying to get rid of, which is kind of a strange thing. You multiply by the exact thing you're trying to get rid of. When I multiply here, I'll have square root of 2 on top, but then on the bottom, I'll have the square root of 4. When you have two square roots, you can take the two items that are underneath the radical sign and they can multiply together. Well, the square root of 4, we know what that is, right? We know that that's just 2. So that's how we're getting this format, right? Those are equal to one another. This is the format that you typically see. As a separate example, suppose that I have the number, let's say 5 divided by the square root of 3. I'll multiply both the numerator and the denominator by square root of 3. And then I'll end up with 5 times the square root of 3. I can't combine those two because one is just a whole number and one is underneath the radical. So they just get set right next to each other, meaning that they are multiplied. And then the square root of 3 times the square root of 3 is the square root of 9, which is 5 times the square root of 3 over 3. This is the preferred way that we write that answer. One more example. Let's do 4 over the square root of 20. So I'll put square root 20 over square root 20. So I get 4 times the square root of 20 over 20, right? If you look at the pattern that we've had, when we multiplied the square root of 2 times the square root of 2, we ended up with 2. The square root of 3 times the square root of 3 ended up being 3. So square root of 20 times square root of 20 is going to end up being 20. And then we want to simplify this fraction, right? The 4 and the 20 have common factor. So we'll end up with the square root of 20 over 5. Let's go back to the example we were doing up here. We got this answer, which is mathematically correct, but it's not grammatically correct. So we will multiply by the square root of 12 over the square root of 12. And then we'll have negative 2 root 12 over 12, or negative square root of 12 over 6. Technically, the square root of 12 can be simplified, can't it? I think we should simplify this a little bit further. The square root of 12 is 4 times 3, right? Anytime I have a perfect square, I can bring that out to the front. Or I'll separate it first. I'll write it as square root of 4 times square root of 3. And this changes into 2. So this is really 2 times the square root of 3. So looking back at this example we were just doing, taking it a little bit further, and bring this guy down here. Negative square root 12 over 6 is the same as negative 2 times the square root of 3 over 3. Sorry, 6, jumped ahead there. And the 2 and the 6 will cancel, and so we'll have negative square root 3 over 3. Again, if you're using the TI-36 calculator, if you type in a fraction, there's a fraction bar, and if you use the fraction bar and type in the square roots, the calculator will automatically rationalize them for you. I'll show you that in class on Tuesday. All right, so there's this sort of funny mnemonic device that a lot of students use to remember where each of the trig functions are positive or negative within the 4 quadrants. And what some people will remember is all students take calculus. I didn't learn this when I was in school, but some students have taught me this. And the way that we use this is to say all 6 trig functions are positive here. All 6 trig functions, let me write it. All 6 trig functions are positive in this quadrant. Every single one is going to have a positive, a plus sign in front of it. Over in the second quadrant, the sign is positive. Since the sign is positive and its reciprocal is cosecant, cosecant is also positive because they are reciprocals. All the other 4 are negative. In the third quadrant, tangent is positive. And because tangent and cotangent are reciprocals, cotangent is as well. All the other 4 are negative. Oh my gosh, I just realized it says it in the picture already. That's funny. I'm rewriting what it says. And then in this last one, C is for cosine. Cosine is positive, and also secant because they are reciprocals. So we're just taking all, oops, didn't want to do that. All Didn't want to do that either. We're looking at S here just for sine, T for tangent, and C for cosine. All right, this is asking us to determine whether the signs are positive or negative for all the 6 trig functions. I think that this should say for these angles in standard position. So we were really just asking us what quadrant are these in? 87 degrees is going to be in the first quadrant, right? Because it's not quite 90 degrees. This is in quadrant 1. And we just said that all trig values are positive because it's in the first quadrant. All right, where's 300 degrees? 300. Well, this would be 180. This would be 270. So it's going to be somewhere over here in the fourth quadrant. So all students take calculus. Cosine is positive. And if cosine is positive, then so is secant, because they're reciprocals. Those are positive, all others are negative. Negative 200. Well, if I go this way, this would be negative 180. So it's going to be a little bit farther than that. So it looks like this is in quadrant 2. So all students in that, so sine is positive. The reciprocal of sine is cosecant. And everything else is negative. Here we have problems that will come up sometimes in applications where we know some things about an angle, but we don't have all the information. This is asking us to use the information to determine what quadrant an angle is in. So it's telling us this first thing is saying that the sine of an angle is greater than 0. This is saying that the sine is positive. And then this one is saying that the tangent of an angle is negative. Well, because one of them is negative, we know that it can't be quadrant 1 because everything has to be positive here, right? In this quadrant down here, in the fourth quadrant, we know that the cosine is positive, but not the sine. So I don't think it's going to be quadrant 4. The sine is positive here. And the tangent is positive here. So I think that based on the fact that the sine has to be positive and the tangent has to be negative, that we're going to be in quadrant 2. Let's look at another example. Cosine is negative. Remember that cosine relates to the x-coordinate, right? So it's telling us that the x-coordinate is negative, and that means that it's going to be one of these two quadrants. Well, secant is also negative, but that is always true when the cosine is negative because they're reciprocals. So in this case, it could be either of these quadrants. So in this case, the answer is quadrant 2 or quadrant 3. I don't think I wrote the answer up here. Quadrant 2. We don't need to worry about this so much yet. We'll be graphing later in the semester, and we'll talk about what the ranges and the domains are of the different functions. But for right now, the one that's the most important for you to know is this very first one, that the values of the sine and the cosine are only going to be between 1 and -1. When we take the sine or the cosine of an angle, it won't be 5 or 30 or 75. It's only going to be numbers that are in between -1 and 1. These other two for tangent, cotangent, secant, we'll come across those a little bit later, but the sine and the cosine being between 1 and -1 is what we want to focus on mostly for this first chapter. All right, here's the example that I was sort of alluding to at the beginning. They've given us an angle, and they told us it's in quadrant 2, and they gave us a sine, and we need to find all of the other trig values. So let's draw a picture to start. Somewhere over here, right? The sine, remember, is y over r. So if I draw a picture here, y is, it looks like, going to be 2, and r is going to be 3. I need to figure out what x is to find the other trig values. So I'm solving this equation here. We'll put x here, 2, 3. We're solving x squared plus 2 squared equals 3 squared. We go back to the Pythagorean theorem. X squared plus 4 equals 9. X squared is equal to 5. So I think that x is going to be, now here's the important part. When you take a square root, there's actually 2 possible answers you can get. You can get positive or negative. So this is either going to be positive square root 5 or negative square root 5. And how do I decide? Well, it's based on the quadrant that we're in. We're in quadrant 2, so we know that the answer has to be negative, right? So this value here is going to be negative square root 5. Now we have all the information we need to find the other trig functions. The cosine is x over r, or negative square root 5 over 3. The tangent is y over x, which is 2 over negative square root 5. We rationalize this. And we get negative 2 root 5 over 5. I can find the other 3 by taking reciprocals. So cosecant is related to sine. So that'll be the reciprocal of the sine. Take 2/3 and flip it upside down. Secant will be the reciprocal of cosine. And again, we have to rationalize. This will be negative 3 root 5 over 5. And cotangent is the reciprocal of tangent. If I look back at this version here, it's easier to see that I just flip that fraction upside down. Negative root 5 over 2. So these are the Pythagorean identities, and they come from the Pythagorean theorem that we've been using all along. I'm going to show you where they come from and show you why they're true. How eventually where we're trying to head is into a unit circle situation where the radius is 1. And so this is what we'll be talking about next week. This coordinate is 1, 0, and this coordinate is also 1, 0. And when I do this, the distance from the origin to any point on the circle, the distance is 1. And so when I draw a triangle, the angle theta here and a right angle here, r is always equal to 1. So when that happens, the sine ends up being y, and the cosine ends up being x, because what we had for sine before, we had sine theta was y over r. But if r is 1, then the sine is just y. And we had that cosine theta was x over r. But if r is 1, then cosine is just x. And so, and this is r. So this is y squared plus x squared equals r squared. It's exactly the same thing that we've been doing to find the missing components of a triangle. We're just using sines and cosines instead. And then the tangent and the secant, those come from the reciprocal identities, which we're going to be talking about in just a second. We've got these quotient identities that will help us see these in a different format. The one that we're going to use the most often is this very first one. The other two are just different formats of the first one that was given to us. What we're going to do right now is use them to solve problems. These two relationships are helpful so that if you find the sine and the cosine, you can get the tangent very easily. If you take sine and divide it by cosine, you'll get tangent. Let's see how that works. We said that sine was y over r, and cosine was x over r. If we multiply by r over r, these r's cancel, and I just end up with y over x, which is the same as tangent. And then similarly, taking the reciprocal, I get cotangent. So these are just sort of shorthand things that you can use that are helpful sometimes. So let's use them in practice. In this case, they gave us just one trig function and we have to find the others. The way we just did this problem was to draw a triangle, which is an option. But what we're going to do here is use one of the trig identities. Let's use the very first one that was given to us, the sine squared of an angle plus the cosine squared of an angle is equal to 1. What quadrant are we in for this? The cosine is a negative number, and the sine is a positive number. Remember, cosine relates to x and sine relates to y. So when x is negative and y is positive, I think we're here in quadrant 2. All right. I don't know what sine is. That's what I'm going to try to solve for. But I do know that cosine is negative root 3 over 4, and I'm going to square that. All right. When you square a fraction, you're going to square both of the components. So if I take the square root of 3 and square it, I end up with 3. And if I square 4, I'll get 16. And that negative sign, negative times negative is positive, so that'll go away. Then I'll subtract the 3 over 16 from both sides. And we have sine squared theta is equal to, so let's see, you can plug this into a calculator, or you're going to do 16 over 16. That's 1, right? Minus 3 over 16. So I think I'm going to get 13 over 16. But I don't want to know what the sine squared is. I want to know what the sine is. So I have to take the square root of everything. When I take the square root of something that's squared, I just get the original thing back. And when I have a square root of a fraction, I can split that up. Square root of 13 over square root of 16. I can split it up into two separate components. So the sine of this angle is the square root of 13 over 4. I don't think I mentioned it, but this notation that we're using here, sine squared theta, what it means is sine, the sine of the angle, and that number, whatever it is squared. That's what it means. We have a shorthand notation where we write the exponent right next to the function, not on the other side of the angle. So it just means that the value, whatever the value of sine is, that number is being squared, is being multiplied by itself. Let's draw a picture just so we can see what's happening here. We knew that cosine was x over r, so that would have been negative square root 3 over 4. And if I were to use the Pythagorean theorem to try and determine what that missing side was, and you can do this on your own, it's going to end up being the square root of 13. But all the work that we just did is a different way of figuring this out. So this would be square root of 13. So this is just showing you that I could take this Pythagorean identity and I could find the other trig values. I've found sine. Now I can use sine and cosine together to get tangent. Tangent is, or I can just do what I just did here, which is draw the triangle. But the value, the functions that we were just given, the formulas we were just given were tangent of the angle is the sine divided by the cosine. So the sine we said was square root 13 over 4, and the cosine was negative square root 3 over 4. There's this cool thing when you have fractions that have the exact same denominators like this, these will end up canceling each other. And we'll just have square root of 13 over square root 3. This is negative, right? Because there's a negative sign in front. Keep running out of room here. And then technically we need to rationalize this. So I multiply the 13 by the 3, square root of 39 over 3. So that's the tangent. And then you can take reciprocals to find the other 3, right? Flip those fractions upside down to get the secant, the cosecant, and the cotangent. All right, I think I'm going to skip this example, leave that there. That's enough for today. If you have questions, send me an email, but we'll probably go over a lot of these examples in class on Tuesday. Thanks for watching. Have a great day.